In today's session, we will discuss about average rate of change. Now, before coming to the formal definition, let us consider an example. Let's say y is equals to f of x, which is defined by the function x. If we try to sketch the graph of this particular function, so this is a straight line which is going to pass through the origin and making an angle 45 degree with the x-axis. So this is a line. Now what we do, we will consider, let's say, 2 points on the x-axis, x1 and x2. And for this particular values of x1 and x2, we will determine its corresponding value on the y-axis. So this is f of x1 and this is f of x2. Now what we want to do here, we want to study how much the y has changed when we change x. So this is referred to as a rate of change. So in a more mathematical term, we see we change x by x2 minus x1 amount. Then we say how much y has changed in going from x1 to x2. So this particular ratio gives us the rate of change. Now in today's lecture, we will discuss about average rate of change as well as instantaneous rate of change. But first, talk about the average rate of change. So here, let's say we have a function given by y equals to f of x. This is a more generalized function. And this function, let's say we are talking only on this particular interval a, b. So in our case, in this particular example, we considered the interval x1, x2. So this is our interval. Now, the average rate of change is given by the value of the function calculated at the endpoint. We subtract them divided by the difference in the interval. So this is how we can determine the average rate of change of any function. So based on this definition, there could be two types of rate of change. We could have a positive rate of change. So in our example, this is a positive rate of change because as we can see, so as x2 is greater than x1, we see that f of x2 is greater than f of x1, which is indeed the condition for an increasing function. And then when we calculate the rate of change, we see that this is a positive value. So this is more mathematical. However, if we want to understand it graphically, it means that as x increases, y also increases, and hence the rate of change, this value is going to be a positive value. Similarly, if we consider that when x increases but the y value decreases, so that is when we have a negative rate of change. Right. So let's understand this idea with the help of a few examples. Problem number 1. So we need to find the average rate of change of this particular function. So this is a power function, x raised to the power of 2 on these 4 intervals. And also we need to determine the rate of change at x equals to 1. So this means this is the instantaneous rate of change that we have to find out. Let's begin by first determining the average rate of change for each of the interval. So we'll consider interval 1, which is between 1 and 2, and this is a closed interval. So here the value of a, this is 1, and the value of b is 2. For this, we'll find out the corresponding functional value. So the value of the function at a equals to 1. So this will be equals to, actually a equals to 1 means at x equals to 1. So this is simply use the function and in place of x, replace it with 1. So this is 1. And for x equals to 2, so this will be equals to 2 squared, which gives us 4. So the average rate of change, so this is simply equals to, we are going to use the formula. So let me note it down. F of b minus f of a all divided by b minus a. So this will be equals to 4 minus 1 divided by 2 minus 1. So 4 minus 1 is 3 and 2 minus 1 is 1. So this is the average rate of change. Moving on to problem number 2. So here we have the interval going from 1 to 1.1. So here the value of a is 1 and the value of b is 1.1, such that the function at x equals to 1, this will be 1 squared, so this is 1, and the function at x equals to 1.1 will be 1.1 squared, which is 1.21, will be equals to, we have f of b, which is 1.21, minus f of a, which is 1, all divided by 1.1 minus 1. So 1.21 minus 1, so that's 0.21, divided by 0.1, so this is simply 2.1. Then coming to the third interval, so here we have 1 to 1.01. So a value, so that's equals to 1, such that f of 1 is equals to 1, and b value, that's 1.01, such that f of 1.01, so that's equals to 1.0201. So the average rate of change, this will be equals to, so we have 1.0201 f of b minus f of 1, which is 1, divided by b, so b is 1.01 minus 1, and this is going to give us the value 2.01. And let's finally calculate the value for the fourth interval, number 4, 0.99 to 1. So here the value of a is 0.99 and the value of b is 1. So f of a, the a value is 0.99. So 0.99, this will be equals to 0.99 squared, and 0.99 squared, so that is 0.9801. And f of b equals to 1, so that's simply value of x at b equals to 1, so this will be 1 squared, so this is simply 1. And our average rate of change value, so this will be equals to, so we have f of b, so that is 1 minus f of a, that is 0.9801, whole divided by, we have b minus a, so this is 1 minus 0.99, and this is going to give us the value 1.99. Now that we have the average rate of change for each of the 4 intervals, so let's write them down in a tabular form. So we have the interval, and then we have the average rate of change. So for the first interval given by 1, 2, so the rate of change was 3. For the second interval 1 to 1.1, so this was 2.1. For the third interval 1 to 1.01, so this was 2.01. And finally for 0.99 up to 1, so we got the value 1.99. So clearly there is a trend that we see here. So as we are approaching the value 1, so we see that the average rate of change is also approaching the value 2. So here we can say that the instantaneous value, the instantaneous rate of change will be 2 at x equals to 1. So this is the instantaneous rate of change. This will be 2 value. Fine. So let's do another problem. Problem number 2. So here we have f of x equals to 1 over x. So we need to find out the average rate of change for each of the 4 intervals as well as the instantaneous rate of change at x equals to 1. So let us begin. Very much similar to the previous problem. All we have to do is follow the steps. So for the first interval 1 and 2, so here the value of a is 1 and the value of b is 2. And for this particular value of 1, so f of 1 will be equals to 1 over 1. So this is simply 1. And for f of 2, which is 1 over 2. So this will be 0.5. That means the average rate of change, so this will be equals to f of b, which is 0.5, minus f of a, which is 1, divided by 2 minus 1, and this is negative 0.5. Coming to the second interval, this is 1 to 1.1. So we have value of a, which is 1. So this implies f of 1. So that's very simple, 1 over 1. So this is simply 1. And b is 1.1, which implies f of 1.1 equals to 1 over 1.1, or 10 over 11. So that means our average rate of change value, so this will be equals to, so f of b, which is 10 over 11 minus 1, divided by b, which is 1.1 minus 1. So this value will be approximately negative 0.909090. Let's come to the third interval. So our third interval is 1 to 1.01. So the value of a is 1, such that f of 1 will be equals to 1 over 1, which is 1, and b is equals to 1.01. So f of 1.01 will be 1 divided by 1.01. So when we calculate the average rate of change, all we have to substitute the value into the given formula, and this is going to give us the approximate value of negative 0.9900. And coming to the fourth one, the fourth interval is 0.99 to 1. So our a value here is 1. So f of 1 is 1, and b value is, now this is the b value. The a value is, this is the b value. So b is 1 here, but a is 0.99, such that f of 0.99, so that will be 1 divided by 0.99. So the average rate of change, so we need to be slightly careful here with the calculation. So we have f of b, that is 1, minus f of a, which is 1 over 0.99, whole divided by b, which is 1, minus a, 0.99. So this gives us the value negative 1.0101, and so on. So we now have the average rate of change for each of the 4 intervals. So let's tabulate all these values. So we have, so for the first interval 1 to 2, we got negative 0.5. For the second interval 1 to 1.1, we obtained negative 0.90909, and so on. For the third interval, which is 1 to 1.01, so we obtained negative 0.99009900, and the fourth one, which is 0.99 all the way up to 1. So here we got negative 1.0101. So clearly there's a trend here. So we see that as we approach the value 1, so the average or the instantaneous rate of change is going to approach the value negative 1. So we'll say that the instantaneous, this is the average rate of change, but the instantaneous is slightly different. So instantaneous rate of change is at x equals to 1. So that means when x approaches the value 1, so our instantaneous rate of change is going to approach the value negative 1. So this is the instantaneous rate of change. Let's go to the next problem. Problem number 3, we have the exponential function. So let's begin with the first interval. So in the interval 1, 2, so we have the average e raised to the power of 2 minus e raised to the power of 1 divided by 2 minus 1, and this value is approximately 4.67. Number 2, on the interval 1 to 1.2. So this will be equals to e raised to the power of 1.1 minus e raised to the power of 1 divided by 1.1 minus 1. So we have a value 2.8588. Number 3, on the interval 1 to 1.01. So the average rate of change, that's e raised to the power of 1.01 minus e raised to the power of 1 divided by 1.01 minus 1. So this is approximately 2.7319. And for the fourth interval 0.9921, the average rate of change value, so this is e raised to the power of 1 minus e raised to the power of 0.99 over 1 minus 0.99. So this is equivalent to 2.704. So let's tabulate each of the values. So we have, so the first interval is from 1 to 2, that gives us a value 4.67. Then we have 1 to 1.1, so this was 2.8588. Then we have 1 to 1.01, the average rate of change came out to be 2.7319, and for 0.99 to 1 it was 2.704. So we see that as x approaches the value 1, so we can see that the instantaneous rate of change at x equals to 1 is 2.7. So this is the instantaneous value, and we also have the average rate of change. So problem number 4, we have the natural log of x function. So let's start. So for interval 1, 2, so that will be equals to, we have natural log of 2 minus natural log of 1 divided by 2 minus 1. So this is going to give us the value 0.693. Number 2, on the interval 1 to 1.1, we have the average rate of change. So this will be natural log of 1.1 minus natural log of 1 divided by 1.1 minus 1. So this is approximately 0.953. This is also an approximate value. Then interval number 3, 1 to 1.01. So here the average rate of change, so that will be natural log of 1.01 minus log of 1 divided by 1.01 minus 1. So this gives us a value of approximately 0.995. And moving on to the fourth interval. Our fourth interval is 0.99 up to 1. So the average rate of change, so this will be natural log of 1 minus natural log of 0.99 divided by b is 1 minus 0.99, and this gives us a value approximately 1.005. So let's tabulate all the values. So we have, so here we see that we have 4 different average rate of change for all 4 different values of the interval. Now if we want to find out the instantaneous value, all we see that there is a common trend here. So this is approaching the value 1 here. So that means the instantaneous rate of change when x approaches the value 1, that value is equals to 1. So we have the sinusoidal function. So let's begin by calculating the first average rate of change for the interval 0 to 1. So we have the average rate of change. So this will be equals to f of b, which is sine of 1. So we have sine of 1 minus sine of 0 all divided by 1 minus 0, and this gives us the value 0.841. Next, for the second interval, 0 to 0.1 equals to sine of 0.1 minus sine 0 divided by 0.1 minus 0, which gives us the value 0.998. Moving on to the third interval. Our third interval is 0 to 0.01 is sine 0.01 minus sine 0 divided by 0.01 minus 0, and this gives us a value of approximately 0.999. And for the interval 4, which is negative 0.01 to 0, which is sine 0 minus sine of negative 0.01 divided by 0 minus of minus 0.01, 0.999. So let's tabulate all the values. So we will have, so we can see our trend here. The trend is, as x approaches the value 0, the instantaneous value is going to be 1. So we'll say, as x approaches 0, the instantaneous rate of change will be 1.